We will conduct an experiment about tensile profile between two types of materials, which is aluminium alloy and mild steel. The purpose of the experiment is to understand and analyze the mechanical behavior between aluminium alloy and mild steel.
Alloy steels are produced by combining steel with additional alloying elements such as nickel, copper, chromium, manganese, silicon, titanium, etc. Technically, every steel is an alloy as it is created by combining iron with carbon. However, to be officially designated as an alloy steel in metallurgy and in the steel industry, the steel must contain one or more other elements in addition to iron and carbon. It is the amount and variety of alloying elements that make the properties of alloy steel different from carbon steel. Adding these elements improves the strength, ductility, corrosion resistance, and machinability of the steel. The low carbon content means that mild steel is typically more ductile, machinable, and weldable than high carbon and other steel. It can be cut, machined, and formed into intricate shapes without adding proportional stresses to the workpiece. However, it also means that it is almost impossible to harden and strengthen through heating and quenching. It has lower tensile strength compared to high carbon steel and alloy steel.
The objective to achieve in this experiment is measure the tensile profile that consists of Young modulus and yield strength. Correlate the tensile profiles with different types of metals, which is ferrous, mild steel, and non-ferrous, aluminium alloy. Analyze the sample fracture surface of both materials, and to determine whether the fracture is ductile, cup and cone, or brittle, clean break. We need the sample, caliper measurement and universal testing machine, UTM. First step, draw a line on the sample. The line should be at the straight surface of the sample. Measure the initial gauge length of the sample. Take the measurement 3 times to find the average numbers. The initial gauge length result for both materials are like this. After that, measure the initial cross-sectional area of the sample. Measure the initial width of the sample. Measure the initial length of the sample. Take the measurement 3 times to find average numbers. The final result for both sample is like this. Next, put the sample on the universal testing machine. The sample must screwed very tight to the machine to prevent from sample sliding away. And then, key in the width and thickness of the sample into machine software. Next, wait for the sample to break. The aluminium alloy doesn't break, but the fracture is ductile, cup and cone. The mild steel is brittle, clean break.
Takut aku tak kena.
Keempat tu
Slow mo. Alamak. Dia jadi macam mana tu? Flat kan?
Tak, yang ni.
Mana yang atas?
After conduct the test, measure the final initial gauge length. This is the final result for initial gauge length. After that, measure the final cross-sectional area.
8.18
8.18. Okay.
Measure the final initial length of the sample.
16.5
Mengukur lagi ataupun itu?
Measure the initial width of the sample.
8.0.
Repeat it 3 times to find the average numbers. The final measurement cross-sectional area is like this. After that, cut the sample into cube 3 cm times 3 cm. This is to test the chemical composition both of the material. By using X-ray fluorescence spectroscopy, the final chemical composition result is like this.